This video is going to talk about ratios and rates with fractional terms. Remember that to find 1/2 of a number, we need to divide that number by 2. For example, 1/2 of 6 apples is 3 apples. What is 1/2 of 2 apples? Well, 1/2 of 2 apples is 2. If I were to ask for 1/5 of a number, I would divide that number by 5. So to find half of a number, I divide by 2. To find 1/5 of a number, I divide by 5. So what is 1/5 of 5 apples? 1/5 of 5 apples is 1, because 5 divided by 5 is 1. Let's look at some of these. What is 1/3 of 3 apples? Well, 1/3 of 3 is 1. What's 1/4 of 4? 1/4 of 4 is 1. What about 1/6 of 6? 1/6 of 6 is 1. What about 1/7 of 7? 1/7 of 7 is 1. Can you guess what 1/12 of 12 is? It's 1. Notice how all these answers are the same. Just like we can multiply 5 times 4 by adding 5 4s, we can multiply 5 times 1/3 by adding 5 1/3s. So 5 times 4 is the same as saying 4 5 times. 5 times 1/3 is the same as saying 1/3 5 times. 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. Remember that when we're adding fractions, we don't change the denominator, because the denominator tells us how many parts make a whole. Instead, we look at the numerator, because the numerator tells us how many parts we have. So if we have 5 parts of 3, that would end up being 5/3, which is actually more than a whole. This is the same as 1 2/3. You probably already noticed that. Let's go ahead and multiply by adding 3 groups of 1/4. So what's 1/4 plus 1/4 plus 1/4? We're going to end up with 3/4. What about 7 groups of 1/5? Well, that would be 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. That's 7 1/5. That means we have 7 fifths. 7 fifths is going to be the same as saying 1 2/5. You try the rest. I'm not going to write out all the addition for all of these. You go ahead and try it. Pause if you don't want spoilers. 4 times 1/3 is the same as saying 4/3, because we have 4 parts and 3 makes a whole. 5 times 1/2 is the same as saying 5/2. You might have changed 4/3 to 1 1/3. You might have changed 5/2 to 2 1/2. 2 times 1/5 is the same thing as saying 2/5. That's just 2/5. That doesn't need to be simplified. What did you notice here? Did you notice that when you were multiplying times a fraction that's just 1 of something, you ended up with the same denominator every time, and it was just the numerator that was changing, and that the numerator was this 3 right here, this 4 right here, this 2 right here? Did you notice that? If not, take a look now. Try these without adding. Go ahead and pause the video so that you don't see spoilers. 1/3 times 3 is the same as 3/3, or 1 whole. 1/4 times 4 is the same as 4/4, or 1 whole. 1/5 times 5, 5/5, 1 whole. 6/6, 1 whole. 7/7, 1 whole. Did you notice how even though we changed the order around, we had the whole number first here, and we have the whole number second here, we're still multiplying the same way? Did you notice that all of these answers equaled 1 whole? Because we took the number of parts that made a whole, and that's the number that we were multiplying by. So if I wanted to turn these 3 fractions into the final answer, what would I need to multiply? 1/3 times what equals 1? How many 1/3s do I need to equal 1 whole? Well, I need 3 pieces to make a whole, and right now I only have 1 piece of 3, so I need to multiply by 3. What do I need to multiply 1/5 by to get a whole? Well, 1/5 times 5 will equal 1 whole. 3/4. What do I need to multiply 3/4 by to get 3 wholes? Well, I know that to get, excuse me, to get 3 wholes, this needs to be something over 4. And if it takes 4 parts to make a whole and I want 3 entire parts, how many pieces would I need? Well, if it takes 4 parts to make an entire pizza, and it's a 3-slice pizza each time, 3 times 4 is 12. So I need to figure out 3 times what gets me to 12, and it turns out that it's 3 times 4. Remember that you can make an equivalent ratio by multiplying or dividing both terms in a ratio by the same number. For examples, the ratios 2:3 and 20:30 are equivalent because the terms of the second ratio are multiples of 10, looking at the first ratio. So 2 times 10 is 20, 3 times 10 is 30. What number can I multiply by to turn the fractional term of the ratio into a whole number? So I want to multiply by a number to turn this into a whole number. Give me half a moment here as I adjust some text settings, please. Uh-oh. Hold on, kids. Oh. Okay. Never mind then. So let's go ahead. To make 1/3, let's look back for a minute. I want to make 1/3 into a whole number, so I would multiply 1/3 times 3 to make it a whole number. 1/3 times 3 would make it 1. Because I'm multiplying 1/3 times 3, I also need to multiply 4 times 3. 4 times 3 is 12. 6 to 1/2. How do I make 1/2 into a whole number? Well, 1/2 times 2 makes it 1 whole, or 2 parts of 2. So I need to multiply 6 times 2. 6 times 2 is 12. That makes it a 12:1 ratio. What do I multiply 1/5 by to get it to be a whole number? Well, I'm going to multiply by 5. That makes 1 whole. So then I also need to multiply 7 times 5 to make it 35. And then I have 1/4. To make 1/4 into a whole number, I'm going to multiply by 4 to make it 1. And then I multiply 7 times 4 to make it 28. Let's go ahead and move on. Let's turn these ratios into ratios where both terms are whole numbers. That's the same thing we just did. We're moving on. Remember that in a ratio table, you need to multiply a row by the same number to get another row. So let's take a look at these ratio tables. Do you see how to go from 1 to 2, we multiplied by 2? So we're going to multiply 4 times 2 to get 8 here. Let's take a look at letter B. 3 times what gets us 6? 3 times 2. So that means we need to multiply 5 times 2 to get us 10. You try the next two. Pause the video now if you don't want spoilers. 1 times 3 gets us 3, so 3 times 3 is 9. 2 times 5 gets us 10. But I can't multiply a number to get to 5. I have to think about what would I do to go backwards. So instead of multiplying by 5, I'm going to end up dividing by 5. So I'm also going to divide by 5 over here. 5 divided by 5 is 1. That one's a little bit tricky. You gotta be careful on that. Nope. A ratio table can also use fractions. Let's take a look at what number do we need to multiply by 1/3 to get 1. Well, we know that if we have 1 slice of a 3-slice pizza, we need to multiply by 3 to get 1. So we're going to multiply 4 times 3 to get 12. Let's take a look at some of these. To go from 1/4 to a whole, I know that I have 1 slice of a 4-slice pizza. I want a whole pizza. I want all 4 slices. So I'm going to multiply times 4, which means I'm going to multiply 7 times 4 to get 28. You try the rest. Pause the video now if you don't want spoilers. 2/5 to get to 2. If I have 2 slices of a 5-slice pizza and I want to get to 2 wholes, 2 entire pizzas would be the same thing as saying 10/5. So to go from 2 to 10, I'm going to multiply times 5. Then I'm going to multiply 3 times 5 to get 15 over here. Over here, I don't know what I want the fraction to turn into, but I do know that 1 to 3 is multiplying times 3. 1/3 times 3 is going to equal 1 whole. 3 slices of a 3-slice pizza. 3 slices of a 3-slice pizza is going to be 1 whole. Same thing over here. To get from 2/10 to 2, well, to get 2 wholes of a 10-slice pizza, I would need 20 out of 10. To go from 2 to 20, I'm going to multiply by 10. And 5 times 10 would be 50. Remember that we can also go bottom to top. And it's the same thing. It doesn't change anything. To go from 1/5 to 1, I'm going to multiply times 5. So here I'm going to multiply times 5 to get 15. And we could continue working on this. I'm going to go through and I'm going to put this down so that the video doesn't get too long. 1/4 multiply times 4. 5 times 4 is 20. To go from 2/3 to 2, well, 2 wholes is 6. I'd multiply by 3. Multiply by 3 to get 12. To go from 7 to 35, 7 times 5. That would end up being 20/5, or 4. Let's say I have a muffin recipe. It calls for 3 cups of flour and 2 bananas. What are the different units here? Well, the 2 different units are the cups of flour and the bananas. How many cups of flour do we need for 1 banana? So let's talk about flour and banana. We know that we need 3 cups of flour for 2 bananas. How many cups of flour do we need for 1 banana? So how do I go from 2 to 1? Well, I'm going to divide by 2. So what's 3 divided by 2? Remember that the fraction bar means division. So this would be 3 divided by 2, or 3/2. You could also write this as 1 and 1/2. Oh, look at that. That's the same table we did, except we wrote it a different orientation than they did. We still got the same answer. The ratios 3 to 2 and 3/2 to 1, they are still equivalent ratios. They still mean the same thing, because by dividing both terms of the ratio 3 to 2 by 2, we got the other ratio. To find a ratio equivalent to a given ratio, it's enough to multiply or divide both terms of the given ratio by the same number. So any two ratios in a ratio table are equivalent. That only works for ratio tables. So let's go ahead and find the equivalent ratios given using the ratio tables. 1/3 to 1, I multiply by 3. 6 times 3 is 18. So the equivalent ratio is 1 to 18. 1/2 to 1, I multiply by 2. And 5 times 2 is 10. So that's a 1 to 10 ratio. Over here, I have 1/5 to 1 is the connection I see. 1/5 to 1, multiply by 5. 8 times 5 is 40. 3/7 to get to 3 entire parts, to get to 3 wholes. Well, 3 wholes, if I have 7, 3 of those is 21, so I need to multiply 3 by 7 to get 21. So 4 times 7 is 28. As a shortcut, rather than using a ratio table, you can multiply both terms by the same number. So, for example, 1/3 to 6, 1/3 times 3, 6 times 3. That gets us 1 to 18. All of these ratios are the same ratio. Let's talk about Ben and how he can paint 3 walls in half an hour. What is the ratio of walls painted to hours? Can you find an equivalent ratio? So, we're going to talk about walls painted. I'm going to call that walls painted to hours. Ben can paint 3 walls in half an hour. How many walls can he paint in 1 hour? 1/2 times 2, 3 times 2, he can paint 6 walls in 1 hour. Good for you, Ben. He has 5 hours this afternoon to paint walls. How many walls can he paint? What happens when there's 5 walls? Nope. Yes, what happens when there's 5 hours? Excuse me. So we can go back to 1/2 and figure out what do we multiply 1/2 by to get 5 wholes. Or we can take this 1 and multiply 1 times 5 to get 5. Multiply 6 times 5 to get 30 walls. That is a lot of walls. Let's take a look at a recipe that calls for 1/3 cup of raisins for every 2 cups of flour. So we are currently looking at 1/3 raisins for 2 cups of flour. How many cups of raisins would we need if we had 12 cups of flour? Well, how do I go from 2 to 12? I multiply by 6. So I'm going to multiply 1/3 times 6. 1/3 times 6 is 6/3, or 2 cups. A newborn Siberian tiger cub gains 2 grams every half hour. Kids, that's a lot. How much does it gain in a day? So if we're looking at 2 grams every half hour, we want to know how much it gains in a day. I could think about how many half hours are in the day, but I'm going to think about 1 solid hour first. So I'm going to multiply 1/2 to go to 1, and 2 halves equal 1 whole, so I'm multiplying by 2. And 2 times 2, it gains 4 grams in 1 hour. How many hours are in a day? If you said 24, you're right. So we're going to multiply times 24 on both sides. 24 times 4 is 96. So that would gain 96 grams in 1 day. Oof. Got a bonus here. For each ratio, we're going to find an equivalent ratio with one term equal to 10. So the first thing I'm going to do is I'm going to go through and figure out which term would be easier to get equal to 10. Well, is it easier to make 2 into 10 or 7 into 10? I think it's much easier to make 2 into 10 because 2 times 5 is 10, 7 times 5 is 35. 4 or 20, which one of those is easier to make into 10? Well, it's easier to make 20 into 10 because 20 divided by 2 is 10, so 4 divided by 2 is 2. You go ahead and try the rest of these. Pause now if you don't want any spoilers. It's easier to get 5 into 10. 5 times 2 is 10. 16 times 2 is 32. It's easier to get 2 into 10 here. 2 times 5 is 10. 3 times 5 is 15. It's easier to get 5 to 10. 5 times 2 is 10. 3 times 2 is 6. 6 tenths. 5 times 2 is 10. 4 times 2 is 8. 30 divided by 3 is 10. 9 divided by 3 is 3. 5 times 2 is 10. 6 times 2 is 12. We could write some ratios that we could find in the room. We could talk about teachers to students, desks to students, tables to students, pencils to students, and square meters of the classroom space to students. So many students. Ladies and gentlemen, I hope that you have an absolutely fantastic day.